Welcome to this room on OWASP API Security Top 10, Part 2. So this is all about APIs. APIs is a lot of websites communicate with APIs, and these APIs communicate with databases or other systems. And they do so using API commands. Let's start this machine. And you'll see it takes a moment or so to start. Then we can click completed. And next, they ask us to call this API endpoint. So API endpoint is like a button of the API. You can sort of think of it like a button. And then it sends a command to the API. We have this command, this link. Every link is a command in an API. So we have this link. You can add some parameters. And when you click send, it returns something. And this is how a lot of communication between databases and websites work. But it also allows you to communicate without a website, as we will do in this TryHackMe room, where we communicate directly with the API, bypassing any websites whatsoever. So it might take a while for the thing to actually load. And now what they want is here that we add this link, so that we make a request, we call that link, and insert the credit value 1000. Now, if you take a look here, you'll see we can specify a parameter and body called credits, and we can simply set it to 1000. So let's do that. In body, we want to add a parameter, and to do that, we need to do a post request. So get is simply to get something from the API, and post is sending something to the API. In this case, we want to set the credit value. So we want to post request, we want to set it to the API. So we do post. Then we add parameter, credit, and we specify it to be 1000. And then this link will be different, as you mentioned here. So instead it will be API rule 6 /user_s. We click send. You'll see it did the request, and we see the output here. So this question is complete. And then they ask us what will be the returned credit value after performing question 2. So that's 50 here. That's simply the result of this link. So when this link is called using the post method, it's simply sending something to that link, and it returns this result. In this case, the returned credit value is 50, even though we sent 1000. So there is some checking there in the API. So 50, you can see here, credit 50. Let's go to the next question. So again, they explain everything. This time, they ask us, is it a good idea or is it an excellent approach to show error logs and so on to the general visitors? And in general, that is not a good idea, because it can reveal all kind of internal things. Maybe it will leak variable names or more things you want to keep secret from the code. It could show that to whoever is visiting, or maybe personal data or user data, customer data. It could show that in an error, which is not what you want to show as an API. So that's no. Now they want us to call this link. So let's call that link API rule 7 /ping_s. Now we need to know, is this a post or a get request they talk about? So let's take a look here in the screenshot. They want us to do the get request. So we change this to get. And then we call that link. So we call the link. You'll see this error here, but that's on purpose. They ask us, what is the HTTP response code? Now, you might not wonder, what is this HTTP response code? So whenever you call a link, underneath is using the HTTP protocol. It's simply how they communicate between your computer and the API. That's called HTTP. And this gives codes back, right? So if the command succeeded, it will give 200 back. And if the command failed, like in this case, it gives 500 back. So the API returns 500, and API returns all kind of codes. 500 means that API is sending you an error. Next, they ask you about an error ID number, and you might not directly see that. However, if you scroll here to the right, you'll see we have an error ID. So if you type that right, it will be accepted. Let's go to the next section. So this is more fun with APIs. Now, they say, can injection attacks be carried out to extract data from the database? So that's the famous SQL injections, and it can get data out. So this is a yes. There's these security vulnerabilities sometimes in database setups or APIs where you give some malicious input and it extracts data from the database. And it can also result in remote code execution, so actually doing things on the computer where the API is running or where the database is running. Now, next they ask us what is the response code if a user enters an invalid username or password. So let's see what they want us to post here. So they want us to do a post request with this link. So that is, we scroll up here, we do a post request. So we're going to send something to the database. Now here, this is one of the famous SQL injections or invalid inputs, that when you give this, sometimes data is leaked, which was the case here. And so what happens is, like a lot of times with these SQL injections or attacks, is that they give all kind of malicious inputs as parameters that nobody would have a password like this or a username like this or other kind of inputs, where the program understands, okay, this is the end of the last command and let's do the next part of the command. So malicious inputs can be really dangerous for APIs. If the programmer was lazy, then it might mean that you have direct access into the database. So let's continue. We have this API rule that we need to change. We now are calling API rule number 8 /user/login_v. Okay, the thing is actually running. So let's see, API 8 /user/login_b, and then instead of this credit, let's click this delete button. Then we want the username. Let's just put something there, and passwords. Let's see what they ask us. Invalid username and password. So I don't expect that there is a user or username A with password B. Let's see. And it returns 403 forbidden. So you see the API can return different codes, HTTP codes or error codes. And in this case, it is 403. So we click submit. And there we go. It submitted that. Let's go to the next one. So here they ask us, is it a good idea to put all APIs on the same server? And they mean different versions, right? So they don't mean having many different servers, but they mean, is it a good idea to have many different versions of the same API or on the same server? So what could happen is if you have version 1 of an API and also a version 2 of an API, perhaps there are vulnerabilities or security vulnerabilities in version 1, and then everybody starts using version 2, but it doesn't mean that version 1 doesn't exist anymore. So it could be the programmers move to version 2. On the website, everything seems fine, but it doesn't mean you cannot call version 1 anymore that has those security vulnerabilities. So it's a bad idea to keep old versions of the API on the server, on the computer, on the API computer. So this is not a good practice. This is nay. So it takes a second. Now they want us to call this link, this command, API command. Let's scroll up and change that. API rule number 9, version 1, user/login. And they want me to use username Alice and password something something. So let's do that. They already have username and password selected here from the last time. And this strange password. And we forgot this dial sign. Okay, and is this a get or post request? Let's double check. So they want us to do a post request to this API rule number 9, version 1, user login. Okay, let's do send. And we get this command. They want to know what amount of balances does Alice have. If we scroll down, we see the result, and we see this balance. Now you might wonder, why do they want us to do this? So actually, it's an example where there's 2 versions of the API, version 1 and version 2. And we are now calling version 1, that is the old version that shows the balance. That might be a security vulnerability that doesn't exist in version 2. So let's say we do this with version 2. And you'll see it doesn't show anything. So it could be that this is the new version. But because the old version is still exposed, we can still get the data, like in this case, the balance. So the amount is on 100. And they ask us the user code. So if we read this data, you'll see here country USA. Then we have the last vulnerability, which is insufficient logging and monitoring. And they give the whole story again. So they ask us, should API logs be publicly accessible? So who is accessing your API might not be the best idea, right? So some people might do attacks, and some people might do all kind of personal commands, and you can see all kind of things that you might not want exposed. So this is an A. And after a successful login, or after a successful link request, it is always HTTP code 200. So that sums up this room. See, there's a lot of interacting with API, which use those links, and those links interact with that API, simply calling the link with data or without data, depending on whether it's a GET or a POST. But it calls those link. Every link is a unique command, and then it interacts with the API. And there can be vulnerabilities, as you've seen here. So we have this vulnerability where we can simply set data and nobody checks anything. So let's say bank account is 1 million and update, and it's set. It is one possible vulnerability in API. It could be misconfigurations that we saw in this one. We can get an error code and things like that. There could be injections, so giving false inputs and then getting correct results or exposed data. For example, here, false input, and then it returned that data. That maybe this authorization key shouldn't be exposed, right? Then we had some other where I think this was the one with different versions. So we use an old version of the API that is still available on the API server on the computer. When there's perhaps they're using version 2, version 3, whatever. But this old version could have vulnerabilities that hackers can still access when you still run that old software or when you still expose that old version on the internet. And then simply some questions about login, that you don't want to show your logs to the internet, right? It's like not something you want to show. So that's it for this room. Let's do complete and just see we completed the room.